This vlog is a visual representation of the analytical process used to evaluate a speed and change of direction drill. 3 athletes are captured in this vlog, which either display a capacity or a skill-based limitation. The key narrative in this vlog is that skill-based problems are in general easier to resolve because they are more features of motor learning, motor planning and cognitive and perceptual determinants. In contrast, capacity limitations often require chronic changes in tissue morphology and tissue physiology, requiring a longer gestation period for the adaptations. The first athlete is a recreational football player executing a 180-degree change of direction drill. The athlete displays a physical capacity problem in that he has difficulty slowing the momentum of his centre of mass before the 180-degree change of direction. Nymphos 2016 has provided a model for the qualitative assessment of change of direction drills. This is characterised by 3 phases. Firstly, the entry into the change of direction phase, the plant phase, which is characterised by deceleration and re-acceleration, and then the exit phase out of the change of direction drill. The attributes which underpin efficient and effective agility and change of direction were originally proposed by Young et al. To include perceptual, cognitive, anthropometric, straight line speed and leg specific qualities to change of direction stepping. The athlete can be seen to achieve top end speed as he enters the change of direction drill, but fails to adequately decelerate his centre of mass prior to the plant phase. In this situation, the athlete's ability to control his centre of mass and apply appropriate eccentric forces in the anti-gravitational muscles, i.e. knee and hip extensors, is poor. This leads to a very poor force absorption as he enters the change of direction deceleration phase at the plant phase, with the athlete requiring several steps to reduce his momentum. More evidence of a capacity limitation is also evidenced in the second video assessing the athlete's ability to decelerate out of a 10-metre sprint, which, although not the focus of this vlog, provides corroborating evidence. The athlete again lacks the ability to decelerate and come to a dead stop. The athlete's ability to stop the forward momentum of their centre of mass is impaired. Again, stopping efficiently requires high ground reaction forces and eccentric muscle action in the posterior and anterior chain. When one considers the hip angle this athlete achieves in the deceleration phase, the angle of the hip is more shallow compared to a comparable athlete doing the same task with greater lower limb, eccentric and concentric strength. This change in capacity requires chronic adaptations in the leg-specific region of change of direction modalities. The derivatives were chosen to improve the athlete's deceleration and absorption of braking forces via the hip, knee and ankle complex. The back squat and split squat with an Olympic bar were chosen to improve his maximal muscle strength. The exercise prescription emphasised the eccentric component of the lifts by manipulating the tempo of these lifts. Jump squats with a medicine ball were also chosen to mimic the reactive strength required in arresting movement during the deceleration phase of a change of direction activity. This can be progressed to drop landing, involving the need to absorb higher braking forces and ground reaction forces. The second athlete is a tactical athlete in the Army Reserve executing a 180-degree change of direction drill. This athlete displays a cognitive perceptual skill problem in that he has difficulties anticipating when it is appropriate to begin his deceleration as he enters the change of direction drill. This drill is new to him as he does not have a background in field sports. The athlete in this video completely overshoots the cone because he fails to anticipate the appropriate time to begin his deceleration phase. It is normal to take several shortened steps to decelerate the momentum of the moving body prior to entry into the change of direction drill. This allows the athlete to assume a balanced body position by lowering the centre of mass and widening the base of support. The greater the number of foot contacts within reason provides a greater interaction between the body and the ground to reduce the athlete's momentum. The derivatives used to improve the athlete's cognitive perceptual skills were to encourage him to start to take abbreviated or shortened steps as he reached the leg press machine. The leg press machine therefore became an environmental cue providing important information about the neuromuscular response required. As can be seen in this comparative photo, the athlete on the third attempt has shortened his stride length in preparation for entry into the change of direction drill. The effect of the cue is dramatic as the athlete no longer overshoots the cone in the plant phase. The speed drill used is a modified fall-in sprint start drill to develop acceleration from a forward lean. The third athlete has a capacity limitation in that he does not display enough force generation in his lower limb extension muscles to develop appropriate acceleration mechanics. The athlete fails to exert adequate horizontal and vertical forces into the ground. This is evidenced by a clear lack of triple extension of the ankle, knee and hip joints during ground contact in the second and subsequent steps. This is fundamental to acceleration and has major implications for force production and impulse to overcome gravity and to create sufficient time to reposition the leg effectively for horizontal propulsion. The athlete also displays poor utilization of arm swing to power out of the drive phase. The derivatives used to develop his lower limb force generating capacity are similar to the activities that we are using for his capacity limitation in his change direction drills. The primary capacity impaired in this drill is concentric muscle strength and rate of force production. Therefore, the intent of the previous exercises must change to account for concentric strength development in regards to training load and tempo of the split squat and back squat. In the drop jump, the emphasis is on the horizontal component for power production because of its dynamic correspondence to acceleration mechanics and the running motion. The second athlete is a recreational hockey player who displays a skill limitation in the modified fall-in sprint start. At the initiation of the start, the athlete achieves appropriate triple extension of the lower quadrant and a positive shin angle to direct the force vector. However, it quickly becomes apparent that her technical skill is somewhat lacking. The athlete's stride length is too long. It should be short and rapid so that it contacts the ground immediately following full extension of the other leg. Keeping the stride length short will increase the stride frequency. However, the athlete's step length more resembles massive bounds, and so her acceleration is stifled because she has limited opportunities to develop force at ground contact and utilize ground reaction forces to generate impulse. Also, the athlete's foot is in plantar flexion in preparation for ground contact, reducing the opportunity to utilize stored elastic energy. An active flat foot encourages the correct landing technique to promote high vertical impulse with each foot contact. The athlete is an ex-swimmer, which becomes evident in the suboptimal arm position the athlete utilizes during the acceleration phase. Although arm swing has received much less attention in the literature, it is often cited as important in sound sprinting mechanics. During the initial acceleration phase, athletes should employ a rapid arm drive in a backward direction in a contralateral fashion to the opposite leg. The contralateral arm drive facilitates hip rotation and leg drive in the forwards direction. This is analogous to the arm swing in a forwards direction that we see performed during the propulsive phase of the vertical jump. The derivative exercises used to improve the athlete's skill acquisition for this drill involved several components. Firstly, the athlete was prescribed a standing arm swinging drill to isolate the technical aspects of arm drive appropriate to sprinting. To reinforce the forward lean of acceleration while emphasizing the maintenance of ankle dorsiflexion, a wall drive was used. Initially, this was slow and controlled, but as the competence of the athlete improved, the skill of execution was increased. To improve the athlete's awareness of appropriate stride length and to improve their efficiency, standing recovery drills were used to emphasize the need to accelerate the leg towards the ground slightly in front of their center of mass. This drill provided an additional opportunity to practice dorsiflexion in the triple flexion recovery phase. The A-skip was used to develop the athlete's front side mechanics to establish a pattern to accelerate the thigh forwards from behind the body to the front of the body in preparation for the transition to the ground preparation phase. Both these drills were used to reduce the athlete's stride length and increase her stride frequency. All these drills were used as a part of the athlete's general warm-up prior to sport-specific training. Therefore, the key narrative in this vlog is that skill-based problems are in general easier to resolve because they are more features of motor learning, motor programming, and cognitive and perceptual determinants. In contrast, capacity limitations often require chronic changes to tissue morphology and tissue physiology, requiring a longer gestation period for adaptations.